Wow. Good morning. You guys are right on time. Try to get you a little closer here. Hey, yo, you too. Happy Sunday. Boy, we could use one. Grinding and grinding. Welcome aboard. Funny you should mention grinding and grinding. You're sitting on a grinding chuck. Yeah, it's a beautiful Sunday morning here in the great state of New Hampshire, and looking forward to another wonderful day. Nice to see you. Welcome aboard. Hey, I think my little experiment with putting notification in the post that if you're not following me, you need to follow me to get the notification seems to have helped. So that's awesome. Welcome aboard, guys. We'll give it a few minutes. Well, welcome, Qualified Monkey in the UK. Good to have you. I would serve you some tea if I could, but all right. Yeah, lots happened this week. Some cool stuff to talk about, both in shop and out. So it was a fantastic week. So the week started with 3 days of Okamoto training, which was really pretty cool. We had Evan Hardy from Okamoto here training, which was part of the deal that I paid for when I bought the grinder. So that was super good. Learned a lot, and we'll talk a little bit about that. Highly recommended to have an expert teach you about the machine you just bought. That doesn't always happen, and it happened this time. Did you get to film any of the training? I did not. I didn't even ask, and frankly, that was a little selfish on my part. I wanted to focus on what I was doing and not on making a video. I learned an awful lot of things, which I am happy to share when we get around to it. But it was excellent, and I'm, for the price, you put things in perspective. It was on order 5% of the cost of my package was training, and that was totally worth it. Unfortunately, it was totally worth it because the manuals are terrible. The manuals are horrible. The software is how do I say this? The user interface. These days we'd say the UX, right? The user interface leaves a lot to be desired, which is not super surprising on any machine tool. I think there's only one machine tool I've ever seen that had a spectacular user interface. So the training filled in. Oh, there's Adam the Machinist and Raven Rock. Both of you, welcome aboard. The training made things clear and filled in a lot of holes, and was very much worth it. So just to reiterate for those joining, I was just saying that Monday, Tuesday, Wednesday of this past week was Okamoto training, and that was great. That was very much needed and very much worth it, and at 5% of my total expense. It was sort of a no-brainer. So Evan Hardy of Okamoto, who is based in Louisville, Kentucky, was my trainer, and he's also an applications engineer. And he was terrific. We had a great time. So, yeah, learned a ton. One of the first things that, we start going over the software. Well, let me explain. The Okamoto software, which is a layer on top of the Fanuc native control, has essentially 3 levels. Level 1 is called semi-automatic grinding. And that's where I'm going to flip you around and show you something here to explain what I'm talking about. So these knobs and switches here are here to be a tie back. Hey, Indiana John. They're a tie back to the old controls, the old school analog switches and knobs controls. So they're here, and they're involved in what they call semi-automatic grinding. So that's kind of the first level, and I had already pretty much mastered that by the time my training started. So that was not a huge part of the training. So we jumped. And by the way, this is another great reason to pay for training one-on-one, because the training goes at your speed and fills in what you need. So that was awesome. So we spent about 5-10 minutes, maybe a little more, maybe 15-20 minutes, talking about what they call semi-automatic grinding. Okay, which is pretty straightforward. Fill in the blanks, use the knobs during training. And that worked out great. The next level in Okamoto land is called full auto grind. And this is what we spent a not insignificant amount of time on. And this was hugely important. So it gets pretty interesting. You can define up to 40 different grinds. And with dressing parameters and everything, and then you can execute a number of them in order. So you can execute like 0, 4 through 14 and have 10 different grinds execute in order. So you could actually have different jobs on the table. Like, let's say you were grinding this Bondo can. Yeah, it's a Bondo can. Don't dwell on that. And then you wanted to come over and grind these stones. It will literally execute, whatever you program for this, and then you come over here and execute whatever you program for this. And that's pretty neat. But I'm excited because my PFG Stone recipe is got a little complexity to it. So I'm able to actually express that in full auto, which is going to make me more efficient, because the way I had to do it in semi-auto was not efficient. So full auto is pretty cool. And then the final frontier is coming over here and hitting this button and going into full Fanuc land. And this is, if you're a CNC guy, you know what that looks like. And we talked a little about that. Evan was not, he was not here to train me in G-code. So we did not do any G-code programming. So that was 3 days, and it was a full 3 days. By the time we were done, hey, Octane, by the time we were done, literally, I was out of questions, and he was out of topics. So it was good. It was fantastic. And he's a great guy. So if you ever have to deal with Okamoto, I highly recommend Evan Hardy for getting your questions answered. Super good guy. So we did that. Evan said, grind every day for a month and you'll be all set. So that's what I've been trying to do, is come up with a little project. And hi guys. Come up with a little project and do something almost every day, because I've got a lot going on, and it's been good. I've been absorbing. I've been becoming one with the machine, and I think we understand each other now. I will tell you one thing about this grinder. That Evan pointed out a few times. It is a very stiff machine. It is a very well-designed, kinematically well-designed machine. It's quite impressive. So, you dial in. I think we were working on something that was mild steel, and we dialed in 4/10 of a grind. And 4/10, it's a pretty good rough grind. I remember making recommendations to people on the Harrig that a 1/1000th was a good roughing grind, and then 2/10 was a good finish grind. Well, yeah, Okie in the garage, exactly right. Well, a 4/10 grind on this thing looked like a 2/1000 grind on the Harrig, and we were kind of theorizing that it's because the Harrig was bending the tool, the wheel pressure. And same thing with spark outs. This thing sparks out pretty nicely and quickly, which says that it didn't move much, didn't bend much when it did the grind. Little things like that. Very pleased with the mechanics of the machine. Couldn't be happier. So everything about that was super good. So amongst the things I did this week is I did a little exercise with grinding out the bow in a bar, which I had kicking around, a little 4-inch bar. So that was sort of my exercise one day. I reground an offset plate, which I posted pictures of, a 6x12 offset plate, which having evaluated after having it for 5 years, had a little potato chip in it. We ground out the potato chip. That all went really super well. What type of parallelism can you get on it? I can't measure the error. So I could measure, the best I have in the shop at the moment, not to include the basement because I have something down there that's better, is 1/10, and I'm getting just 0.00. So couldn't be happier. So one of the other funny things that happened during training is I kept using PFG Stones. It's my normal workflow. I stone the chuck, I stone the work. Just routinely, I kept, and Evan picked up on it. And let's just say that he left here with a gift, and he knows how to use them now. So that was pretty cool. And it's a little, I told him, I said, listen, you could do a magnificent grind and then you use the PFG Stones and it's going to tell you the truth. So if you don't want to know the truth, be careful. So I was a little concerned because we had reground the chuck. I said to him, I said, look, you do what you would normally do. And he said, well, normally we would grind the chuck. I said, grind the chuck because I want to watch and I want to see his procedures. And I learned something about how he used the control, which was pretty cool. He used, I think he used semi-auto. He dialed in a very deep grind, but with in very fine steps, and I think it was 1/10. And he kept on going until the chuck cleaned up. And then once the chuck 100% cleaned up, he hit a button on the control, which was stop downfeed. So now the grinder froze in its position and just kept going, which means it was sparking out. So he let that go for a while. It was a pretty black belt way to use the control. And that was one of my learning points. So that was pretty good. But after the chuck was ground, and it measured perfectly. I mean, within the uncertainty of an indicator hanging on the wheel housing. And then after that, of course, what did I do? I got out the PFG Stones and I stoned the table. And it, in fact, showed some pattern to the grind. And a chuck, probably the hardest thing you're ever going to grind. Let me clarify that. The most difficult thing you're ever going to grind is the chuck, because it's this combination of soft materials, and it's not easy. So it showed up some action on the chuck, and I think that's what opened his eyes to PFG Stones. And then I said to him, just because you see a pattern doesn't mean it's not precise. It doesn't mean you can even measure it, but it is telling you what's going on, and that's what happened. Hey, I'll show you what I mean. Let me flip around here. So you can see a little pattern in the chuck, and I don't think it's important, but it's there, so it teaches you something, and you can improve. You can improve your process, and that was the whole point. So that was kind of fun. And then on Wednesday, I did some G-code programming, and we started grinding pins. And I posted, hey Tom, I posted pictures of, we got questions coming in. I posted pictures of the pin grinding, and that was a pure G-code thing, because we had to start from an assumed position of 100 thousandths above the pin. We came down to include, I think, a tenth. We came across while the pin was rotating, of course. Came across, came back, went up, all in incremental, so you could hit the button again and take off another tenth. And that's kind of the G code we wrote. And I'm going to expand on that to make a little library of pin grinding G code, so that I can pull that up and use it as needed. But it was fantastic, and we started improving and debugging the pin grinding, and that pin represented some future projects that I have in rotary grinding, so that we had to get that working. So let's see, we did have one question pop in. So can you elaborate on the PFG Stones? Well, it's PFG, and that stands for Precision Fine Ground. It may stand for something else. If you go to the website pfg.gg, you'll learn everything you need to know. Okay, so PFG Precision Fine Ground.gg, and you could learn all about PFG Stones. It's my product. I sell it, and that is a commercial. So go buy PFG Stones. In one sentence, we take a stone, we grind it as flat as we possibly can with a diamond grinding wheel, which sounds easy. It ain't. You can do pretty good, but it's hard to get it really good. And I've spent the last, I think we're going on 3 years making it really good. So there you go. Hope that helps. Go to pfg.gg and get yours today. All right, moving on. So that was Okamoto Training. It was awesome, and I love this machine. It's fantastic. So you know, it has its warts. I shouldn't say the machine has its warts. The machine is the machine, and it's primo. The software, it's a little stumbly. It's, you know, once you learn it, and here's the thing, this is what the training did. Once you learn the software, it's fine, but it's sort of a pain. Yeah. Thank you about the diamond wheels. You could DM me about that, but let's not make a commercial for your guy that sells diamond wheels. I will say that I've been buying diamond wheels from Continental Diamond Tool. Hashtag not sponsored. And they're wonderful. USA made diamond wheels. That's the other thing, Shrum Solutions. I'm happy to take a DM from you about that, but if it's not made in the USA, not interested. Don't get me wrong. I buy lots of things not made in the United States, but if I could buy diamond wheels made in the United States, that's where I'm going to buy them from. So, with that said, if you guys have any other questions, put them in the question button down below, and we can talk more about that. All right, Shrum. We're on the same wavelength. So that was the week. That was Monday, Tuesday, Wednesday. Thursday, I don't remember Thursday. This was a week. I might have taken... No, I took Friday off. I chilled out on Friday. Thursday, I think I got some day job things done, having been away from the office. Literally been away from the office. I didn't walk in the office, at least not to do anything for the Monday, Tuesday, and Wednesday. So we got back, and then Friday was a day of rest. And then Saturday, being yesterday, I had my black belt test for my 4th degree Taekwondo black belt. And that was all, well, it was from 10 a.m. to about 2:30. And then we went out to celebrate. And that was the rest of the day. So I was toast. So today I'm recovering from that. Great day, and that was awesome. And there you go. So I promised a laser update. So down in the basement, in the 3D printing laser calibration lab, we had some good success with the laser. We're now laser marking the stones. Indiana John says, was that at summer camp? So no, it's not summer camp. I don't go to summer camp. My son goes to summer camp, but Dad works all summer. So I've been studying Taekwondo for, I guess, 20 years now. I haven't done the math, so I could be off. I go 3 times a week, typically. Some weeks a little more, some weeks a little less. But I train 3 times a week, and I also teach. So it's been, I don't talk about it a lot on Instagram. I've started more lately, but that's a major part of my life, and it's really helped me out. And my daughter got her black belt also, and my son has done a little bit. So Taekwondo has been a big part of this family. So let's see. So down in Laserland, we've been using our fiber laser. We're now marking our stones. The TKD summer camp is a 2-day thing, once a year. That's awesome. I love getting kids exposed, and see if they could really love it. My daughter absolutely loved it. My son, a little less so. So my daughter, went all the way through getting her black belt. And I should point out that our school, if you're curious, by the way, another website for you, get your pencil ready. You can go to UTKD, that's United Taekwondo, utkd.org. utkd.org, and you can learn about our school. We're a nonprofit school, been around for over 30 years, very family oriented and absolutely serious Taekwondo from associated with the Kukiwan loosely, and it traces back to our grandmaster Mu Young Lee, who came to the United States as a teenager and became a Taekwondo teaching legend. So, and that lineage continues. Okay, so that was the week. I was going to tell you about the laser. Both your sisters are black belts, and your little brother is red belt. Excellent. Please give them a fist bump for me. What part of the world are you in? I guess you're in Indiana. Are you in Indiana? Hello. I like it when usernames contain names. It just helps. Anyway. Okay. If you have Taekwondo questions, put them in the question button down below. I will answer them, but I want to keep going here so we don't run out of daylight. Laser update. We've been laser marking stones. So all the new stones. Oh, you're in Wentworth, New Hampshire. Dude, that's awesome. Well, if you ever get down this way and you want to come to a class at our school, you are most welcome. Shoot me a DM, okay? And check out the website. Wentworth, New Hampshire. I'm trying to think if I know where Wentworth is. I will look on a map later, but nice to make your acquaintance. I'm going to talk about the laser if it kills me. So we're laser marking stones now. I'm an idiot because I don't have an example to show you, and I don't want to unwrap some new stones. But right along the edge here, and you guys are going to find out about this. Hey, Chuck, welcome aboard. Cool beans. You guys are finding out about this before the rest of the world, okay? So we're marking, we have the KP logo, the model number, and PFG.GG on the edge. And all of these markings are done after precision grinding, after grinding is finished, and it makes a subsurface mark. So it doesn't affect the use of the stone at all, and it's highly unlikely that you're ever going to rub it off. But it's really nice. It's a nice marking. And I was just convinced, and I'm going to tell you guys something that I haven't said to anybody, but it'll be on the website soon, and soon means when I get around to it. We're going to have the normal marking, and then for an additional, like a tattoo, for an additional cost, if you want custom marking on the other side, we're going to offer that. So if you want to put your name or the shop name or whatever, we're going to have a fixed price. Not exactly sure what it is. It's not going to be a lot. Hey, there's John. How are you, John? And then if you want to do a logo, you'll have to DM me, okay? Can mine say Renzetti Stones? Yes, it could. Although I think you might have to get. We have to find out if the name Renzetti is trademarked or copyrighted. In which case, I don't want to violate a copyright or a trademark. But yeah, that would be a good tribute. Yours can say, and Adam, just for you, yours can say anything you want. Anything. Okay. So so we're gonna have that capability, and I think that's pretty skookum. Oh, and let me show you one more thing. This I do have handy. Let me show you. So we're also going to mark the trays. All right. So I'm trying to get the light on that. There you go. So the trays are made of PETG, and I 3D print them. And of course, because I have a fiber laser, which is the short wavelength laser meant for engraving metal, It's not supposed to work with, plastic. Not supposed to. It makes a nice mark. So the trays will be marked also, which is a new thing, which is, it's not going to make them any flatter, but there you go. So the laser's been a pretty cool tool, and it's now sort of it's in the production line. So we're pulling trays off the 3D printer. They go 5 feet to the laser. They get marked, and when the stones are done upstairs in the shop, and they're done with all grinding, all deburring, all cleaning, and all QC, they go down to the basement and they get laser marked. So if a stone is laser marked, it's gone through all that process. And then we will print out a sheet of the people that have custom markings, and then we'll do the second side custom markings, and then they come back up for packaging. So that's the new workflow. And it's working pretty good. And the additional cost of that workflow is nothing. And one of the reasons I could do that is because the efficiency went up so high because of the grinder. I'm actually able to walk away from the grinder for 20 minutes or whatever and do something else. So now my efficiency went up. We could do all these niceties, and it makes me very happy. It makes me unreasonably happy. So the laser's been pretty kick-ass, and I've been very happy about that. Alrighty. You guys have any questions? I promised you something last week that I would talk a little bit about today, and one of the guys that I promised it to, I'm kind of waiting for him to show up before I dive into it, but he might have to. What time is it? He might have to wait. We'll see. But if you guys have any questions, hit the question button and throw it in there. And I'm going to have a sip of tea. Excellent. So what are you guys doing in the shop this week? That's what I like to ask you guys. What's going on? Give me a couple of words here and tell me what you're doing. Oh, we have a question. Let's see. Oh, I owe you another MIT joke. Did you like last week's MIT joke? I'll see if I can come up with one. If not, I'll tell you an MIT story. Is that okay? Adam is stamping die parts this week. I assume you're making the dies. Am I correct? Oh, stamping die. Hang on. I got to get my words grouped together. Stamping die parts. Got it. Yeah. Oh, by the way, I bragged about you, Adam, when the Okamoto guy was here. So, there you go. So, okay, I'll tell you an MIT story. This is an old one that very few people know about, unless you were there. And actually, I don't even know if a lot of the new. Well, I think they get trained on this. There was a phrase that came out of one of the bio classes at MIT, which had to do with determining the sex of a toad. And it was toad sexing. So if you go through some of the secret passageways at MIT, you'll see written on the wall in pencil or Sharpie the phrase "no toad sexing," and maybe even the little symbol with the slash. So that is a little symbol of you are on the path. You're in a secret hidden passageway. You'll see little signs nearby that say no toad sexing. I know that's weird. I could hear you all thinking that's weird. And if I'll try to think of another MIT joke before we're done today. All right. Here's a question. Do the stones wear down over time? Everything wears down over time, including me. They are surprisingly long-lived, and that's because, you know, what wears something down is high pressure, not high force, high pressure. So it's one measure of pressure is pounds per square inch, right? So if I take my, let's see, I need a couple of, hang on, I gotta grab something. Okay, let me answer this question. So, if I take a stone, all right, you guys know what I just did? Hang on, let me show you. Take the stone out of the tray. Notice they're two different sides up, right? So the dark side is down on this one, and the light side is down on this one. So we're going to use the dark side. We're going to use the dark side. So I'm going to lift this guy, condition the stone, and that's what you do every time before you use the stone, okay? And now I'm going to apply it to a piece of work. So here's a ground bar. You can see it's very pretty, all right? And I put that down, okay? And I'm doing two things here. I'm feeling and I'm listening. And the feeling and the listening, you hit the wrong button. Are you with us, Chuck? Okay, and voila, I've stoned this side. Now, my fingers tell me that this surface was damn good, and my ears tell me the surface was damn good, and then I use my eyes, and what do you see? This is real hard to show you on camera. There's a little dark spot in the middle, okay, and there's a little dark spot at this edge. So there was a little bearing. There was a little bearing in the center, okay, and there was a little bearing on the edge, and I don't see the same thing down here. So there might have been a little shape to this, but probably not. The next thing I'm going to do, and I'm getting back to your wear question. I just want to show you the proper way to use these. The next thing I do is I take my wiper, which is attached to my hand, and I just wipe off the marks. Okay, I've observed the marks. Now I'm going to wipe them off. And then I'm going to look at the surface again and see if there's anything permanently left. Like, did I shine anything up from the stone? And on this guy, the answer is no. I can't see any shiny spots on the stone. Conclusion, it's a good flat grind. And those slight pickups were probably from me deforming the bar, okay, and putting more pressure in the middle. All right, so I just went through sort of, this all happens in 5 seconds. This is not like it take a lot of time. So now to answer your question about wear. So how many pounds per square inch? Let's say I put 5 pounds on the stone when I was stoning, which I didn't, probably less than that. But let's say I put 5 pounds, and let's say this is 5 square inches. I put about 1 pound per square inch, 1 PSI, between this material and the stone, okay? And at 1 PSI, nothing's happening. Nothing's happening. So if this is perfectly flat, and my stone is flat, and I'm putting these together, and I'm ending up at 1 PSI, then nothing happens. What if I have a burr on the surface? So if I have a burr that is super surface, is above the surface, and I put the flat stone on it, and I put 5 pounds, and because of a miracle, the stone and the work are perfectly parallel, so only the burr touches the stone. How many PSI are between the burr and the stone? Many. Big. Okay? So what happens is big PSI causes something to move. And in this case, the thing that's hard tends to not want to move, and the thing that's soft tends to move, and you take off the burr. Once the burr is gone and you're back to flat on flat, it drops back down to 1 psi, and it doesn't cut anymore. And you could literally stay here, you know, for the rest of your days, and nothing's going to happen. So that's the story about how to use the PFG stones. Now let's talk about wear. It's not a hard curve. It's not a, oh, at 1 psi, nothing happens. Well, it's not so true, because stones are very, very hard particles, like the things we want stones for, surrounded by less hard material, which is the material which is what vitrifies. It turns into a glass to hold all the bits and pieces. That stuff is actually kind of soft. So that's what makes a stone friable, and that's what makes a grinding wheel friable, which means it falls apart when it gets too many PSI on it. So stones will wear. If you use them properly, it's amazing how long they go without. I have not worn out a set of stones. Okay, the people that and only on 2 occasions did I have stones in the field come back to me for a regrind, and those were abused, and I happily reground them and send them back out, and they were abused. But if you use the stones the way they're intended, which is not for it's not for knocking off a burr off the corner of a piece of stainless you just machined, okay? That's a different stone that you could pay $8 for. Have at it, okay? You don't care if that stone wears out. PFG stones, that's not what you use them for. So they go a long, long way. And what I tell all my customers, and it's on the website, and it's on every product every PFG stone I sell, if you feel it's not performing, I'll regrind it. Maybe a laser mark can check if it wears down. So you're brilliant. Thank you. That is a brilliant thing, and we can do that. We can put in a laser mark. I mean, honestly, I'll have to think about it if it's worth it. But my practical experience is, boy howdy, you got to work pretty hard. The other thing that happens is, if you properly condition the stone, whatever tiny amount of wear happens, when you condition the stone, the same thing happens. You're sharing the wear to the other stone, and eventually they flatten themselves out again. And especially if you randomize, you know, how you use the stone, you're encouraging that flat to stay put. And it will. So if you own a set and you use them for a while, you realize they go for a long time. It's more important that you clean them occasionally than to think about if they're worn out. And you'll know if they're worn out because, well, they'll stop acting, they'll stop gliding correctly. But I haven't had anybody wear out a stone if they're using it properly. I hope I answered that question, and I hope that was useful. Maybe we'll cut this out and use this as a little training video. Excellent question. Okay, I think we have another one. Hey, so Chuck asks, do the stones self-true against each other? The answer is yes. But stunningly slowly. Like, yeah, Indiana John. Your Whitworth is showing, not Wentworth. Your Whitworth is showing. Yeah, you don't need 3 in the set. Trust me. You actually have 4 surfaces. And oh, by the way, it's totally fine to mix the colors. Right? There's nothing wrong with that. So really, you already have 4 surfaces, and you can mix and match and randomize them, and that's all fine. So the stones do self-true, but you will not live long enough to see, a stone going from out of true to true. They're just very hard, and the PSI. Remember, we talked about the pressure is pretty small. So, but that's why we clean them. We say that we're cleaning them when we condition them. The side effect of that is they are doing what you're talking about, but it's on such a tiny scale that it's. And what happens when you take any material? What happens when you take any material where you have 2 similar hardnesses and you put them together? It gets weird. It's weird physics. Okay, so Chuck, I hope we answered that question. Rubbing them against each other is a good idea, and cleaning them, every now and then with a solvent, it's a good idea. So I didn't mean for this to be a tutorial on stones, but you guys have excellent questions. I will take any other questions before I give you your. Thanks, Chuck. Your weekly bonus is. Oh, I didn't do the second part of my thing. Let me just back up 1 second. So this is, I like to learn with examples, right? So this looks like about 1 pound per square inch, right? And we could do this all day long. Like Captain America says, I could do this all day. Okay? Now, what if I did this? This is a carbide scriber. What if I put the same pressure on the carbide scriber and rolled it around? What would happen? I would wear my stone. I would start wearing my stone. How many pounds per square inch? If I put 5 pounds on the stone, how many pounds per square inch are on that scriber? And the answer is effectively infinite. Okay? So that's why one of the things we do for a demo, and I'm not going to do this on this stone because it's my nice stone, is take a stone and scribe a line on it and scratch the crap out of it. And then you go and condition the stone and you can still use it because it's subsurface. So when you think of pressure on a stone, you got to think of the difference between a big area and a little area. That made you uncomfortable? Excellent. Then I did my job. My job here is done. Remember, it's all pasta, okay? It's all pasta. Some of it's cooked, some of it's uncooked, but everything is pasta. Robin says that everything is rubber. Okay, I think everything's pasta. All right. Any other questions? We got 10 minutes, and then I'm going to call it. I'm going to have some tea if that's okay. Oh, by the way, there's a laser mark I did on the fiber laser. That's called annealing. They call it annealing, but it's an oxide mark on stainless steel, and you can't feel it. And I have some future projects coming up where we'll be using what they call an annealing mark on tool steel. I have a tool steel product coming up, and we're going to mark it like this. Isn't that cool? I marked it while the tea was in it as I posted. Okay, who wants to see some stuff about antennas? Because I said last week that I would do a little antenna thing. So give me some thumbs up if you want to see some antennas, and I will show you some antennas before we quit. Oh, I see one hand up. While you get your hands up for an antenna demo, I'm actually going to do a demo for you. I'm going to take this ground bar and I'm going to scratch it real hard. All right. Another hand. All right. You see the scratch? Okay? So if I go to feel that scratch, it's a serious scratch. I could feel it a lot. So if we take our stones, I'm going to take my I'm conditioning. There's a stone, and let's see if you can hear this. I'm going to bring it right close to the microphone. Little hard to hear when you grind on the corner. Yeah, there you go, Indiana John. Bingo. Woohoo! All right, this smoothed out. This just smoothed out. I could hear it. I could feel it. Now let's look at our mark. Again, I'm not going to clean this bar. I'm just going to show it to you. Okay? You see it's now black. Okay, what did we just do? Let's read the tea leaves together, okay? We just removed the burr I raised from the scratch, plus, look up here. We stoned enough to bring out some residual imbalance, which I'll leave for another day, in the wheel, okay? Now, I'm going to wipe it off. Ready? So after I wipe it off, what remains is really the scratch. Now, I cannot feel the scratch. It is all, wheel hop, correct. It's all subsurface. And can I see evidence after wiping it off? Can I see evidence of the wheel hop? And the answer is a little bit. Tiny bit. So we did have a little residual imbalance probably in the wheel, but my fingers say that surface is back to perfect. So there's a quick demo on how the stones get used. Okay, I wanted to talk a little bit about balancing, but let's do that next week because I made some discoveries balancing. And I'm going to push it to next week. But I'm very happy about some of the discoveries. In short, I found a little bow in my arbor that I used to balance wheels, and I corrected it. And I believe that was introducing a balancing error, which I saw in some of my work, like that bar, okay? I'm going to try to prove that. But then I subsequently, with a perfect arbor, I subsequently rebalanced my wheels very carefully and started using some new methods, which I'm going to teach. And I'm very happy with that, and we'll see some more of those results this week. Okay, I promised you antennas. I want 5 more minutes. I'm going to show you some antennas. So some of you know that my day job is antennas and not sitting in front of a grinder, even though it seems like that. So I'm going to come over here and show you some goodies. Turn the camera around. Okay, so let's see. If you know something about antennas, you know that this is an antenna called a Yagi-Uda array. A Yagi-Uda array means that it has a driven element. There's the connector. Okay. That's called an N connector. So it has a driven dipole. And then all the other elements are not connected electrically to anything. Okay. In this case, they are insulated. And this is a 5-element array. That's what we call it. Okay. And that is a Yagi-Uda array. So this one was designed for some special applications for military UHF SATCOM, and this was for making measurements, and that is an example. So these little plastic parts, that's actually a prototype. I've since redesigned them, but I have a standard insulator which I make, And then, of course, the center insulator and Ballon is also something that I make. You could recognize that as Delrin, and I'm using Delrin here. The future ones, there's one way up on the rack there. You can see the back of it. I use black Delrin because black Delrin is superior in the world of ultraviolet. So that's an example of why I have a shop. So I can come downstairs, make these parts, make these antennas. The antenna is designed using software called CST Microwave Studio. And we do a lot of simulation, optimization with a very, very powerful computer running very powerful software for, hours and to get the design. The design looks wicked simple, but it's not wicked simple. Tell me if that sounds familiar. Let's see. Another antenna. This one's a little heavier. This is called a Krauss helical. Okay, so this is a, if you want to get technical, this is a monofilar, cylindrically wound helical antenna working against the ground plane. Hey, Dika. And that is an antenna that is very wideband. It's directional, and it transmits and receives a circularly polarized signal, in this case right hand signal, circularly polarized. And then on the back is the connector. Where is it? There it is. Another end connector, some of the hardware, and the mount. The mount's pretty cool. Let's see if I can do this one-handed. The mount is symmetrical, and it is very flexible. So this gets mounted to the boom, and then you could use U-bolts to mount to a small mast or a big mast. And that's a part that I made, designed a few years ago. Actually, now it's a lot of years ago, but that's pretty cool. So that is a Krauss helical antenna, named after John Krauss of Ohio State University fame. John and I were friends, and he passed away, and I miss him. He's a super good guy. And no, I did not go to Ohio State University, before you ask. So that's the second antenna I want to show you, and we're coming up on the end of our day here. But let me put this down. I'm doing this one-handed has been very interesting. Let me put something on the floor. There's another view of it. And then this guy is an R&D antenna that I did for a customer who shall remain nameless. Which side am I opening? Oh, sorry. There we go. Let's see. Talk about a machine shop antenna. All right. So this antenna is a Cassegrain reflector antenna. It's 15 inches in diameter. It looks like it's about 15 inches in height. This is the main reflector. This is a sub-reflector. The customer supplied the sensor that went on the back. So my job was to design and build the reflector. And let's see. Yeah, there's my engraved mark. Hey, Morgan. So this reflector started as a 40, let's see if I can remember this, a 40-pound block of aluminum. So this started on the mill, and the whole back surface was done, and actually the periphery was milled. And you can see it has a bunch of lightning holes. There's a couple of these pins. This is a nice feature.
This is I call it a D pin. So that's what it looks like on that side. And that's what it looks like on that side. Okay, so this pin has got two features. It's got the flat, which indexes it in rotation, and then it's got a screw that holds it tight up against the machine surface. So that puts that screw in the right place, and more importantly, it puts this surface right here in the right place. And we do that 3 times to support the spider, which supports the subreflector. Another feature on here is there's 2 bolt hole circles for mounting. Okay, there's an outer bolt hole circle and an inner bolt hole circle, and then there's this inner recess. Now, when I got this job, I went to talk to the PFG. Listen to me, the PhD, whose project it was, and they had 2 equations for this antenna. That was it. They knew nothing else how to make an antenna. And I took those 2 equations, which was the curvature of the main reflector and the curvature of the subreflector and the distance between them, and I had to turn it into what you see here. So the little machinist's secret on the back of this antenna is that this recess and this bolt hole circle makes it look exactly like an adapter plate for the TL1 lathe. So I was able to mount this on a standard adapter plate, put it right on the TL1, and turn this to do the front side. I thought that was a clever hack. So then we turned it over. By the way, this is 17 pounds right now. So we started with a 42-pound block of aluminum here. The block of aluminum for this guy was probably 4 or 5 pounds, maybe 4 pounds here, and then another 4 or 5 pounder here. Now this whole assembly is 17 pounds. So once this goes on the lathe, the front surface was done on the TL1, and except for all the fingerprints, you see there's a ton of fingerprints here. This guy went to metrology and was probed all over, and we held, never actually talked to the PhD. You know, that PhD was actually pretty cool, and he knew what he didn't know. So I can't complain. It was a good job. So the TL1 did this parabolic surface, and it did this inside hole, which is what everything references off of. So this is sort of the datum. And yeah, we probed less than 2 thousandths all over. And that was the goal. And then we have these struts, and then it comes up to it, the spider. I like the spider. It's one of my favorite parts. The spider holds the subreflector, more lightning holes, and plus I designed them a fine pitch focusing feature so that they can move the subreflector in and out to focus it, and they didn't think of that. So we took care of that. And the other thing that's interesting about this design, besides from an antenna reflector point of view, is that there's 3 different alloys used here intentionally. This is yeah, that's true. I think we started. The good news is it was I was able to use the equations directly in SolidWorks to generate the curve. And at the time, I was using, let me think. I'm trying to remember the cam I was using. It'll come back to me later. It actually worked out pretty good from a programming point of view. And then the tooling was interesting. I used a boring bar because I needed something long enough to do this. So that was actually done with a boring bar and very sharp aluminum, highly polished tools. Let's see. Oh yeah, three alloys are used here. This alloy is a cast aluminum alloy, so the material wouldn't move when we cut it. This alloy, and that was Alpay's M1. It could have been Mike 6. There's a bunch of them. This guy here is 6061 extrusion, and that was, and these guys were all machined in a fixture. The fixture allowed both ends of this thing to be machined at the same time to get these little, you see that little cut right there? That was important. The distance between that cut and that cut is what set the nominal distance here, so that was important. And then finally, 2024 aluminum was used for the spider because it had a lot of threading in it. And then the subreflector was that cast aluminum material, same as this reflector. So yeah, there was a lot of machining and mechanical engineering that went on here. I was very proud of that project. Made 2, delivered 1. It's probably in a vast government warehouse next to the Ark of the Covenant. But that was a pretty cool project. So you asked for antennas. We went a little overtime. I'm sorry. I gave you antennas. Cassegrain reflector antenna, minus the sensor, which is none of my business. Yagi Uda array. Professor Yagi was the professor, and Uda was the graduate student. That's why we call these Yagis now, because everybody forgot Uda. We will not forget Uda. It's a Yagi Uda antenna. And a Krauss helical, invented by John Krauss. Good story. He went to a lecture by a physicist, and the physicist showed a helical winding being used to direct a beam in a tube. And John Krauss said, "Hey, I wonder if we could use that for an antenna." And the physicist said, "Yeah, that won't work." So he went back to his lab and he said, "I think it will work. So I think I'm going to make a 1 wavelength circumference and a 1/4 wavelength spacing," and boom, it worked right out of the gate, and it was almost perfectly optimal. And thus we have the helical antenna. And if you look around, you'll see these everywhere. Well, not everywhere. You'll still see them on the moon. You'll see them on every GPS satellite. Yeah. Thank you, John. Thank you. Okay. I think we did it. I think we've come to the end of our hour, and that was fun. The question light is not on, so that means I answered every single question you have. And I want to wish you guys a super rest of your weekend. I hope you get some relaxing time. I'm going to get some relaxing time and ice my elbow again. That was not a Taekwondo injury. I was pre-injured, but I'm taking care of it. All right. Any other questions? You guys are awesome. I'm going to put you back on the Bondo can here. Have a little more tea before I say goodbye. Indiana John, I'm glad you liked it. Yeah, I love antennas. I've been doing antennas now for over 25 years, which is crazy. And I work for myself. My company is Antennasis. If you go to my links, go to my bio, follow the links page, you can learn more about some of what I do. The antennas came before the machine shop, but the machine shop is an important part of my story. All right, guys, this will be up on IGTV. I was trying to remember the name of it. So if you missed it, you're probably not hearing this, but it'll be up on IGTV. Have an awesome Sunday, and get flat and stay flat. Oh, the brake dresser. Yes. You see, you've got to bring it up. I'm happy to talk about it, but it's next week, I think. So next week, I'm writing it down, and after I finish writing it down, I'm going to hit the big red button.